Good morning, everyone. I am Akanksha from Sri Venkateshwara College of Engineering, studying 4th semester in Bhaskara section. Today, I am going to explain about properties of relations in discrete mathematics. Introduction to properties of relations in discrete mathematics. Relations in discrete mathematics are a fundamental concept that describes the connection between elements of sets. Understanding the properties of relations is crucial for analyzing and solving problems in various mathematical contexts. Different problems of relations helps in classifying and characterizing the nature of relationships between elements. So the first one is reflexive property. A relation or on a set A is reflexive if A comma A belongs to R for every element A in A. In simple terms, a relation is reflexive if every element is related to itself. For example, the relation is equal to on the set of integers is reflexive. Symmetric property. A relation R on a set A is symmetric if for every A comma B belongs to R and also B comma A that belongs to R. It is known as the symmetric property. In other words, if A is related to B, then B is also related to A. An example of a symmetric relation is a sibling of it relation. The next one is transitive property. A relation R on a set A is transitive if for every A comma B belongs to R and B comma C belongs to R and also A comma C belongs to R. This property signifies that if A is related to B and B is related to C and then A is related to C, the is divisible by, that is a word. It refers to relation on the set of integers which are transitive. Antisymmetric property. A relation R on a set A is antisymmetric if for every A comma B belongs to R and B comma A belongs to R and then A equals to B. This property states that if A is related to B and B is related to A and then A must be equals to B. The is less than or equal to. It is a word that refers to the relation. It is an example of an antisymmetric relation. The difference between symmetric and antisymmetric property is in symmetric, the property states it is if A is related to B, then B is related to A, then A is also related to C. But in asymmetric property, if A is related to B and B is related to A, then A must be equals to B. Okay. Irreflexive property. A relation R on a set A is irreflexive if A comma A which is not belongs to R for every element A in A. This property indicates that no element is related to itself in a relation. The is not equals to relation is an example of irreflexive relation. Equivalence relation. An equivalence relation on a set A is a relation that is reflexive, symmetric, and transitive. Equivalence relation partition the set into disjoint subsets called equivalence classes. Examples of equivalence relations include is congruent modulo n and is equals to. The next one is partial order relation. A partial order relation on a set A is a relation that is reflexive, antisymmetric, and transitive. Partial order relations represent a partial ordering of elements in a set based on certain criteria. Example of partial order relations include is less than or equal to and is a subset of. Total order relation. A total order relation on a set A is a partial order relation that is also total, meaning of any two elements are comparable. Total order relations establish a complete ordering of elements in a set. The is less than or equal to relation on the set of real numbers is a total order relation. So the conclusion is understanding the properties of relations in discrete mathematics is essential for solving problems in various mathematical fields. Reflexivity, symmetry, transitivity, asymmetry, and other properties helps in characterizing and analyzing relationships between elements. Equivalence relations, partial order relations, and total order relations are key concepts that utilize these properties in discrete mathematics. Thank you everyone.